In late 2025, something started shifting beneath the surface of global infrastructure quietly, almost invisibly. It wasn't a headline, it wasn't a scandal, and it wasn't the kind of crisis people fight about on television. Instead, it was a pattern, a subtle but unmistakable signal. The world's largest corporations were suddenly buying up water infrastructure at a pace that defied every historical norm. These weren't flashy acquisitions. No announcements, no press tours, no triumphant executives ringing bells at stock exchanges. It was all happening in silence. And that silence is exactly what made it terrifying. Because for decades, water infrastructure has been considered the least sexy asset class on Earth. Slow growth, high maintenance, boring returns. But now it was being bought with the same urgency companies showed when scrambling for semiconductor fabs or lithium mines. Something had changed drastically and abruptly, and if you look closely enough at the data, you can pinpoint the pivot to a single quarter Q3 of 2025. That's when acquisition volume didn't just rise, it exploded. The total value of private purchases in that 3-month window exceeded the combined total of the previous 20 years. Let that sink in. 2 decades of transactions compressed into 1 quarter. But here's what makes the pattern even more unsettling. These companies weren't diversifying. They weren't spreading risk. They were concentrating everything on a single category treatment plants, pumping stations, subterranean pipelines, and long-haul transport systems. And they were doing it on every continent. Australia, Spain, Chile, South Africa, the American Southwest. Regions that share just one thing: water stress. A vulnerability that worsens slowly, then all at once. But here's the twist. The danger isn't coming from droughts or climate models. It's coming from something much harder to detect: accelerated aquifer collapse. A technical phrase for a nightmare scenario. The underground water we rely on is disappearing far faster than scientists predicted publicly. And that brings us to the leak that started the panic. Mid-2025, an internal research memo circulated through only a handful of environmental agencies. It was never meant to reach the public. But a single chart from that memo escaped, a map showing 21 countries with groundwater reserves collapsing 70 times faster than projected. 70 times faster. That single revelation triggered a global buying frenzy. Not by governments, not by environmental groups, but by private capital. Because they understood what the memo implied. Water shortages weren't a 2050 problem. They were a 2027 problem. And once that information reached certain investors, the acquisitions began, quietly at first, then aggressively, and soon frantically. But here's the part almost no one knows. The warning signs actually began 2 years earlier. In 2023, 3 major utilities in California documented sudden drops in available supply. The public explanation was reduced usage, but that wasn't true. Internal logs showed something far more frightening: declining source availability. In other words, the reservoirs weren't being preserved. They were hollowing out. That report was shown to 14 people. Every one of them doubled or tripled their water sector positions within the year. So the real question isn't why water companies are being bought, it's what these investors already know. And more importantly, what the rest of us don't. Because the data doesn't just hint at a coming crisis, it screams it. And once you understand the trigger behind this invisible emergency, everything else snaps into place. But the darkest part? The country most vulnerable to the first wave of collapse is the one nobody expects. In the next section, we'll reveal where this silent collapse began and why the earliest warnings were ignored until disaster neared. To understand where this silent collapse truly began, you need to go back to a place almost no one pays attention to: a thin stretch of desert on the border of northern Mexico and the American Southwest. On maps, it looks empty. But beneath that empty land sits one of the largest fossil aquifers in North America, a reservoir formed tens of thousands of years ago. It was once considered limitless, untouchable, eternal, but in 2022, field sensors scattered across the region began returning strange readings. Not the usual seasonal fluctuations, these were sharp, sudden drops in pressure. At first, researchers assumed equipment failure. So they replaced the sensors. Same results. Replaced the cables. Same results. Replaced entire monitoring stations. Same results. The data was telling a story nobody wanted to hear. The aquifer was collapsing from the inside out. Still, the findings were buried. Not because of conspiracy, but because nobody believed them. They contradicted decades of hydrological models, entire university textbooks, billions in infrastructure plans. So agencies filed the data away under anomalies and moved on. But the anomalies didn't stop. By early 2023, 2 additional aquifers in Spain's Donana region and South Africa's Karoo Basin showed the same warning pattern. Sudden inward pressure failures, forming what scientists quietly called subsurface voids. Imagine a massive underground cathedral beginning to sag, its ceiling thinning by millimeters each month until gravity finally wins. That's what these aquifers were becoming, hollowed-out chambers dissolving under their own weight. The earliest warnings came from hydrologists working in these regions. But these scientists were cautious by training. They didn't shout, they wrote. They sent memos, drafted internal reports, and attached detailed charts to emails that few people ever opened. In another timeline, one where governments acted quickly, those reports might have triggered global alarms. Instead, they triggered yawns. After all, the surface looked fine. Reservoirs remained full. Tap water still flowed. Crops still grew. Politicians still smiled for cameras while ribbon-cutting new desalination plants. The idea that a continent-wide failure was brewing underground felt impossible. But by mid-2024, the first visible cracks began to appear literally. Small sinkholes started opening across agricultural zones in Spain and New Mexico. Not dramatic Hollywood craters, but subtle circular cavities about a meter wide. Farmers filled them in, cursed under their breath, and went back to work. They didn't know these holes were symptoms of a system losing structural integrity. What finally caught corporate attention wasn't the sinkholes. It wasn't the scientific memos. It was the supply chains. Because water flows through global business long before it flows through taps. Soft drink manufacturers in Mexico reported unexpected production pauses. Farming conglomerates in Spain documented irregular irrigation pressure. Mining companies in South Africa quietly suspended operations for reasons that were never disclosed publicly. These were whispers, minor disruptions scattered across industries that rarely talk to each other. But to the right analysts, those whispers formed a pattern too loud to ignore. And that's when the real turning point happened. A major logistics firm analyzing its operational delays discovered something chilling. Every delay in every affected country traced back to one single cause: declining groundwater pressure. Not drought, not policy, not climate trends, pressure. The firm escalated the finding to its parent corporation. That corporation escalated it to an asset management partner. And within weeks, a chain reaction began. Meetings were held behind closed doors. Private forecasts were drafted. And the most unsettling phrase in those documents was one that would never appear in public reports. Projected systemic failure within 36 months. That phrase set everything into motion. The acquisitions, the secrecy, the silent global scramble for control. But there was still one missing piece, one question everyone inside those meetings kept asking. If groundwater collapse is progressing this quickly, what starts the cascade? What event triggers the visible crisis? The answer was discovered by accident, thousands of miles away in a laboratory that had no idea what it had stumbled into. And in the next section, you'll see how that discovery changed everything and why it proved the collapse was not only coming but accelerating. The discovery that changed everything didn't come from a government agency or a global think tank. It came from a research technician working the night shift at a hydrology lab in northern Japan. The lab wasn't studying aquifers, groundwater collapse, or anything remotely related to the crisis unfolding underground. They were analyzing microfractures in volcanic rock, routine work, dull work, the kind of data no one checks twice. But this technician noticed something unusual. A cluster of microfractures forming in patterns that shouldn't exist unless enormous pressure was being redistributed beneath the surface. At first, he thought the readings were noise. But the anomalies persisted night after night, spreading outward like an invisible ripple. He forwarded the findings to a senior researcher who connected the dots instantly. The fracture signatures didn't match volcanic activity. They matched something else. Rapid subsurface decompression, the same kind that happens when groundwater retreats too quickly, leaving voids that destabilize surrounding rock. The lab cross-referenced its data with public geological maps, then with private satellite scans from a partner university. The result was terrifying. The pressure wave was part of a global chain reaction. Within weeks, scientists in Chile and Turkey reported similar patterns. Then Australia, then Spain. The same fingerprint everywhere, microfractures forming months, sometimes years, earlier than models predicted. It meant the internal structure of major aquifers wasn't just slowly weakening, it was entering a phase of accelerated collapse. One researcher described it like this: "We thought the dam was leaking. In reality, the dam was crumbling, but what truly shook the scientific community was the speed at which the collapse signal propagated." Under normal geological circumstances, pressure shifts travel slowly, inching through layers of sediment. But this wave moved quickly, far too quickly, suggesting that once a critical threshold was breached in one region, neighboring regions were pulled into the same failure pattern. It wasn't local, it was systemic. And still none of this reached the public. Not because scientists were hiding it, but because they didn't yet understand the implications. Nobody wanted to risk triggering panic over incomplete data. So the report circulated quietly among institutions, gathering dust in folders labeled preliminary. Meanwhile, corporations were moving at full speed. By late 2024, sensor companies supplying equipment to water agencies noticed an unusual spike in bulk orders from private buyers. Firms that normally purchased a few dozen units suddenly wanted thousands. And not the cheap sensors, the advanced ones capable of detecting micro variations in subsurface pressure. Someone out there wanted real-time intelligence. Someone was preparing for something big. Then came the corporate flights. Not the public ones, chartered jets heading to remote agricultural sites, desalination plants, and isolated reservoirs. Teams of executives walked the perimeters with engineers, taking notes, running tests, placing bids on assets that weren't even listed for sale. It was a global scavenger hunt, and every clue pointed to the same conclusion: the window to act was closing. But the most alarming signal came from the investment side. A major European fund abruptly reclassified water infrastructure as a strategic vulnerability, a label previously reserved only for energy grids and nuclear facilities. That reclassification sent shockwaves through the world of private finance. It meant internal models were predicting cascading failures, not isolated shortages. And still, the public heard nothing. Households kept watering lawns. Cities kept approving developments. Nations kept signing agricultural export deals. The surface reality looked stable, almost calm. But beneath that calm, the timer was ticking. Scientists now understood that once a certain collapse threshold was crossed, the shift wouldn't unfold over decades, it would unfold over months, maybe weeks. And the threshold, according to the newest data, had already been crossed in 3 regions. The frightening part? Those regions weren't the ones everyone assumed would fail first. And in the next section, we'll explore the country that experts now believe will experience the first visible breakdown, a place where the crisis will hit quietly at first, then violently, and without warning. The country most experts now believe will face the first visible breakdown, is in Thai, one of the usual suspects. It's not a drought-stricken region in Africa, nor an overexploited basin in the Middle East. It's a nation most people imagine as stable, wealthy, and technologically prepared: South Korea. On paper, South Korea looks like the last place a water crisis would erupt. It has world-class desalination research, dense urban planning, and some of the most advanced infrastructure standards in the world. But beneath that impressive exterior hides a vulnerability so sharp, so mathematically unavoidable, that analysts now believe it will be the flashpoint of the global cascade. The problem starts deep underground, in the country's fractured bedrock aquifers, narrow geological formations with limited recharge capability. For decades, these aquifers provided supplemental water during dry seasons. But heavy industrial expansion in the 1990s quietly pushed withdrawal rates past the natural recharge limit. Officials assumed the damage was manageable. Models predicted decades before any structural instability. But remember the pattern from earlier sections: the models were wrong everywhere. In late 2023, small rural towns began reporting a strange phenomenon. Wells that had been stable for generations suddenly dropped by several meters within weeks. Engineers blamed mechanical failure. Local governments blamed farming practices. But when the National Water Authority compared readings from hundreds of sites, a chilling trend emerged. The pressure decline was synchronized, almost perfectly, across regions that were supposed to be isolated from each other. That shouldn't have been possible. Groundwater systems don't behave like synchronized clocks unless something beneath them is collapsing simultaneously. Then came the industrial alerts. Semiconductor factories, the backbone of South Korea's economy, started issuing private notices about irregular cooling output. This was unprecedented. These plants rely on hyperstable water pressure to maintain manufacturing precision. Even a minor fluctuation can ruin thousands of wafers. Executives quietly contacted government agencies. The agencies quietly contacted hydrologists. And the hydrologists quietly confirmed the unthinkable. Korea's aquifers were undergoing the same accelerated pressure failure seen in Spain, South Africa, and the American Southwest. Except in Korea, the consequences would hit much faster. Why? Because the country's water-dependent industries operate on razor-thin tolerances. A subtle drop in water pressure interrupts semiconductor production. A small shift in groundwater stability jeopardizes entire transportation corridors. A single sinkhole forming beneath a logistics hub could freeze exports nationwide. And that's exactly what specialists fear will happen first. In early simulations run by a private research consortium, analysts modeled what would occur if pressure loss continued at the current pace. The outputs were worse than expected. Localized sinkholes forming under industrial parks, microfractures compromising high-speed rail foundations, abrupt failure of older municipal tunnels, inland saltwater intrusion affecting coastal cities. None of these events alone would trigger national panic. But together, they form the opening wave of a cascading collapse, one that could unfold in a matter of weeks. By mid-2025, international insurers quietly raised premiums on Korean infrastructure projects, citing structural uncertainties. A few months later, two major investment funds withdrew from long-planned water-intensive factory expansions without public explanation. Those decisions barely made the news. But for analysts who understood the signals, that was all the confirmation they needed. The collapse wasn't hypothetical anymore. It was already unfolding. Still, the most revealing sign wasn't economic. It came from something far simpler: satellite imagery. High-resolution scans showed subtle, unnatural shifts in soil elevation across multiple provinces. Not dramatic enough for the public to notice, but unmistakable to experts. The ground was quite literally sagging. Now, here's the real nightmare. Once the first visible failure appears, whether it's a factory shutdown, a collapsing roadway, or a sudden halt in rail service, it will already be too late. Because visible failures are not the beginning. They are the result of years of invisible collapse. And Korea is only the first domino. In the next section, we'll examine how a failure in one technologically advanced nation triggers a global chain reaction, economic, political, and infrastructural that spreads far beyond water itself. When a country is technologically advanced and globally integrated as South Korea experiences an infrastructure shock, the impact doesn't stay inside its borders. It spreads quietly at first, then violently through every system connected to it. And because Korea supplies everything from semiconductors to automotive components to battery materials, even a temporary disruption in water stability becomes a global event. Imagine this. A single high-precision chip fabrication plant slows production because groundwater pressure drops, just enough to interfere with cooling systems. Not a shutdown, just a slowdown. Output dips by 8%. That 8% ripples outward to companies relying on those chips. Smartphone delays, automotive bottlenecks, cloud server shortages. Each industry compensates by overloading its remaining suppliers in Taiwan, Japan, and the US, pushing those systems closer to failure. All from a water pressure fluctuation invisible to the public. But that's only the first layer of the chain reaction. The second layer is geopolitical. Water instability isn't like an energy shortage. You can't import groundwater at scale. You can't ship aquifer pressure across an ocean. So when a nation realizes its industrial backbone is threatened, it shifts priorities. Export-oriented economies turn inward. Governments restrict key materials. Supply contracts quietly collapse. Investors flee volatility. And alliances begin to strain. Because here's the truth nobody wants to say out loud. A water-driven industrial slowdown in a single major economy acts like a tremor beneath the global financial floor. Markets react not just to the event itself, but to everything it implies. Rising insurance risk, fragile supply chains, unpredictable manufacturing output, and the possibility, however small, of cascading failures across multiple aquifer-dependent nations. And that leads to the third layer: infrastructure interdependence. Most people never think about how tightly woven modern systems are. A semiconductor shortage slows electric car production. Electric car shortages affect lithium demand. Lithium fluctuations shift mining patterns. Mining shifts change port activity. Port changes impact freight routes. Freight congestion disrupts food imports. Food disruptions trigger political tension. All of this can trace back, in part, to one destabilized water network on the other side of the planet. This is why the corporations who understood the early signals moved so quickly. They weren't buying assets to profit from scarcity. They were building defensive walls around the collapse they knew was coming. Meanwhile, national governments moved slower. Publicly, they reassured citizens. Privately, they commissioned emergency audits. And the results of those audits were worse than anyone expected. Multiple countries, not just South Korea, were operating with aquifer systems already past the stability threshold. Some were wealthy, some were not. Some were industrial powerhouses. Some were agricultural giants. But they all shared the same hidden fragility: groundwater dependence far exceeding long-term recharge. And the most dangerous part? When one country experiences visible collapse sinkholes, shutdowns, structural failures, others follow, not because they are physically connected, but because the confidence in global water stability breaks. Investors panic. Supply chains reroute. Governments hoard, markets tighten. The world reacts to the signal more than the substance. It's the same psychological trigger that turns a bank withdrawal into a bank run. Once the world sees the first domino fall, every nation with even a hint of groundwater stress becomes a suspect. Every corporation with exposure to water-intensive production faces pressure. Every investor rebalances. Every headline fans uncertainty. And that's exactly why the biggest players have been repositioning quietly. They know that the water crisis won't begin with physical scarcity. It will begin with perception, the moment global confidence fractures. But to understand how that fracture becomes a full-scale collapse, you need to see the final layer of the chain reaction, the one nobody talks about publicly: how governments plan to respond once the crisis becomes undeniable. And that part is far more unsettling than the collapse itself. In the next section, we'll explore the emergency policies being drafted behind closed doors, and why they may reshape the global balance of power for decades. Behind closed doors, governments have already begun drafting emergency policies for a world where groundwater can no longer be trusted. These documents aren't part of public debates, they aren't mentioned in press briefings, and they certainly aren't posted on state websites. They circulate quietly encrypted briefings, restricted memos, eyes only. Summaries shared among ministers who know that admitting the truth too early could spark the very panic they were trying to avoid. The first policy category is rationed industrial allocation. Not household rationing, not yet. Instead, governments plan to choose which industries receive stable water flow and which ones are sacrificed. Semiconductor cooling, protected. Food processing, protected. Textile dyeing, chemical manufacturing, lower value agriculture. Cut, not reduce cut. The logic is brutal but simple. In a crisis, nations prioritize sectors tied to global leverage. The second category is forced regional consolidation. When pressure drops below structural thresholds, water agencies can no longer justify maintaining dispersed networks. Neighborhoods, then towns, then entire districts may be consolidated into fewer, more defensible supply zones. This means relocating communities, abandoning unstable infrastructure, and shutting down remote service lines. These decisions are politically radioactive, which is why they remain hidden in draft folders labeled contingency. The third category is the most controversial: privatized emergency partnerships. Governments plan to grant unprecedented control to corporations that already hold advanced water technologies: filtration, atmospheric extraction, high-efficiency desalination. In exchange, these companies will receive long-term concessions over parts of national water grids. On paper, it's a lifeline. In reality, it's a shift in power, transferring authority from public hands to private entities that have already positioned themselves ahead of the collapse. But the fourth category is the one that keeps analysts up at night: cross-border water intervention protocols. These drafts quietly acknowledge what no official will say publicly: that water scarcity doesn't just destabilize infrastructure, it destabilizes governments. Nations experiencing collapse may face forced migration, economic seizures, and strategic vulnerabilities. Nearby countries are preparing military, humanitarian, and logistical frameworks to respond, some to help, some to secure their own interests first. This is why intelligence agencies track groundwater pressure now with the same urgency they once reserved for nuclear tests and missile launches. Because pressure loss in one region can trigger political shockwaves in another. And when those shockwaves intersect with financial instability, food insecurity, or weak governance, the result is not gradual decline. The result is sudden fracture. Yet here is the most unsettling truth of all. None of these emergency policies address the core problem. They manage symptoms. They slow the bleeding, they buy time, but they do not reverse the collapse. Because the collapse isn't driven by mismanagement or temporary drought. It's driven by physical laws, pressure, density, decompression, structural fatigue. Once a system crosses certain thresholds, policy can only cushion the fall. That's why corporations acted early. That's why investors repositioned. That's why insiders bought water infrastructure instead of tech stocks or energy futures. They aren't planning for a temporary disruption. They're preparing for a reconfiguration of global stability itself. And the most important lesson for anyone watching, whether investor, policymaker, or ordinary citizen, is that the crisis will not arrive with a dramatic headline or a single catastrophic event. It will arrive quietly. A factory slowdown, a sinkhole, a pressure anomaly, a series of unexplained delays. Each small failure will look manageable, until the pattern becomes impossible to ignore. By the time the public understands what's happening, the real decisions, the ones that shape the next decade, will have already been made. And that raises the final question, the one this entire story has been building toward. In a crisis where the most valuable resource isn't oil, gas, or even technology, but water itself, who controls the future? Because the people who saw this collapse coming didn't just prepare for it. They positioned themselves to own the world that emerges afterward.